So for Chapter 7, this question is going to be, what is the effective nuclear charge of aluminum? And this is going to be a neutral atom, so we're not going to be working with an ion. So basically what we're going to start off with, and I've already written everything down just because it gets a little twisted in my head sometimes. So this is the equation for effective nuclear charge. So the Z is actually going to stand for the atomic number of the atom that we're working with, which is going to be aluminum, so that's going to be 13. And then the S is going to stand for the screening constant, which the screening constant, in this case, or in any case when you're working with effective nuclear charge, is going to be essentially the core electrons that are kind of blocking that attraction between the nucleus and the valence electrons. So we've already written down the equation. I already put a little note here that we're talking about the core electrons when we're referring to the S. So what we need to start off with is the electron configuration. So I went ahead and wrote that down already, and how we get this, of course, is you go through and you have 1s across the top, 2s, and then you have 2p, and then from there you go 3s, and then 2p. So this is going to be the 1 here, and I have all these numbers written down because, of course, for the S subshell you have the 2, and then the P you have 6 electrons. And I went ahead and divided these up already. So when you look at the representative elements, which are these and these, of the periodic table, you can already tell the valence electrons of their group numbers. So this one's going to be 3A, so we're going to have 3 valence electrons. And of course back here you're going to have 1 and you're going to have 2. So that kind of makes it easier when you're going through and you're doing the electron configurations, trying to figure out the valence electrons for those. So we already know that this has 3 valence electrons because you've got the 2 and then the 3. So we've separated those already. So again, when we go back here looking at the screening constant, we're trying to find the core electrons. So here's going to be the core electrons here, so we've got 10 of those. So again, we're going to go ahead and plug those into the equation because we need the atomic number, which is going to be 13. We're going to subtract 10 from that, and that'll give us plus 3. And I have another way of doing this as well. If you go through and you actually kind of put 2 and 2 together, you can look at the aluminum atom here, and it's got a 13 for the atomic number, and so that's actually going to mean that it has 13 protons and 13 electrons, and that's again for a neutral atom. So if we write down that it has 13 protons and 13 electrons, then we can gather that it has 3 valence electrons from the group name, which is group 3A. So that means it's got the 3 valence electrons. And from there, we can kind of subtract the 13 overall electrons here. Subtract the 3 valence electrons from the 13 electrons. And then that gives us a number of 10 for the core electrons. So then we can go back and we can plug those into the equation. The 13 for the atomic number minus the 10 core, and that gives us a plus 3.